In this chapter section, we are going to take a look at the electrochemical cells that rely on the non-spontaneous redox reaction. Please read more detail of this chapter section on the OER textbook, chapter section 18.5. The electrochemical cells that rely on non-spontaneous redox reaction is called electrolysis. Electrolysis is the opposite of the galvanic or voltaic cells, because in order to drive the non-spontaneous redox reaction to occur, it will require the ongoing outside energy, in this case would be electricity, to drive the reaction to occur. On the other hand, for the galvanic cells, since they rely on the spontaneous redox reaction, the galvanic cell would produce electricity. Here, let's take a look at the two examples of the electrolysis reaction. One is the electrolysis of water, and the other is electrolytic cell for silver plating. Let's focus on the electrolysis of water first. For the decomposition of water to hydrogen gas and oxygen gas, this reaction is non-spontaneous. In order to drive this reaction to occur, we will need the external source of electricity. In order to determine which element is undergo oxidation and which element undergo reduction, you will still need to do the same identification of the oxidation number. In this case, oxygen would be -2, hydrogen would be +1. The elemental hydrogen would be 0, the elemental oxygen would be 0. Therefore, in this case, you will see that the hydrogen going from +1 to 0, therefore hydrogen is undergo reduction. And for oxygen, it's going from -2 to 0. Therefore, oxygen is losing electron. Oxygen is undergo oxidation. And as you see here, the oxygen that undergo oxidation, right, it would be part of the anode. And the hydrogen that undergo reduction would be part of the cathode. Right, so that would be the redox couple pair, right? So for example, in this case would be oxygen in water that become oxygen gas molecule, and for the redox couple pair for the cathode would be hydrogen in water that become hydrogen gas that is reduced. To get the overall reaction, pretty much you will need to combine these two half reaction. But before you can combine these two half reaction, please note that the number of electrons are not the same. You will see 4 electron transfer from the anode, but the cathode accept only 2 electron. Therefore, you will need to multiply the reduction half reaction by 2 first before you can combine these two together. So if you do this, you will get 2 water from the anode plus 4 water from cathode plus 4 electron, and it's going to become oxygen gas from the anode plus 4 proton from the anode plus 4 electron, and plus 2 hydrogen gas from cathode plus 4 hydroxide ions from the cathode. Because 4 electrons are appear on both sides of equation, so we can cancel that, which means that this half reaction they transfer 4 electrons between each other. And if you look at the reaction between the 4 proton and the 4 hydroxide that is available, these 4 proton and 4 hydroxide would react with each other and form 4 water. Therefore, in this case, you also observe 4 water on both sides of equation as well. Therefore, you can cancel the 4 water. Therefore, the overall reaction that you will obtain would be 2 water that dissociate into oxygen plus 2 hydrogen gas, which is exactly identical to the overall reaction that we see here. In order to determine the spontaneity of this reaction, you can use the E cell that come from the reduction half reaction potential of the cathode minus standard reduction potential of the anode. By looking at the list of the standard reduction potential that will be given, this is going to be in page that is belong to chapter section 18.3. But on the exam, this table will be provided for you. And if you look up the value, the standard reduction potential that belong to the cathode, that belong to this water that become hydrogen here, is equal to -0.83 volt. And the standard reduction potential for the anode, which is belong to this one right here, is positive 1.23. Therefore, the standard cell potential for this electrolysis of water would equal to negative 2.06 volt. The negative value indicates that this reaction is non-spontaneous. And in order to make this non-spontaneous redox reaction to occur, it's required at least 2.06 volt to drive the reaction to occur in the non-spontaneous direction. The application of the electrolysis of water is that the collection of the hydrogen gas that is produced can be used in the hydrogen fuel cell that we learned earlier. That if the hydrogen gas combine with the oxygen, that reaction is going to be spontaneous reaction, which is the opposite direction of this non-spontaneous reaction, right? So if the reaction is non-spontaneous forward, the reverse process would be spontaneous. Therefore, if you have oxygen and hydrogen react together, it's going to occur spontaneously in the reverse direction, and that application is used in fuel cell, hydrogen fuel cell that we mentioned in the previous chapter section. Another application for the electrolysis is in silver plating or in any metal plating. For example, if you have an object that needs to be plated by the silver, what you need to do is you will need to have the silver electrode, and the object that you will need to it will need to be plated. If you submerge these two together without any energy supply, the reaction will not occur. The object still going to have its own color. However, this non-spontaneous redox reaction can be driven by the voltage, the external voltage that we'll need to supply. It's going to drive the reaction in such a way that the silver electrode will release the silver ions, and the silver ions will travel to the object to be plated, and that silver ion would accept electron on this electrode. Therefore, the silver ion that accept electron would become the silver solid deposit on the object. So this is the process of silver plating. Eventually, the color of the object will be the same color as the silver that coated on the surface of the object that is plated. This idea is similar to gold plating and other type of metal plating, which rely on the electrolysis reaction that are non-spontaneous reaction, which require electricity to drive the reaction to occur. Please read more detail of this chapter section from the OER textbook, chapter 18.5.